So the next thing we are going to be going over is the flue gas analysis type stuff. Okay, so one way that we can commonly measure oxygen, carbon monoxide, nitrogen oxide, nitrogen dioxide, and sulfur dioxide is we can use an electrochemical cell that uses voltage to cause a chemical reaction. So let's briefly kind of explain how that works. If I can find my chalk. Okay, so the first thing that we have here is our gas permeable membrane. Gas permeable membrane. Okay, so essentially what is happening, all right, is our oxygen is being taken into here. And you see all of this blueness here? This is all water. And using electricity, we can basically combine the oxygen and some of the hydrogens and form what we know as hydroxide or OH, which is all these green dots here. And I'll explain why they transfer and how they transfer in a second with that arrow. All right. What we have up here, this long line here, this is called our cathode, okay, which is negatively charged. And this is often stuff like made up of, in this case, platinum. Okay, this here, this line that connects it, and you can see there's this entire battery and all these electrical lines going. This here is a circuit. Okay, it's our electrical circuit. We have our battery here, which produces like the electrons that are going to flow through this line. So here we have our cathode line. Again, this is providing power to our cathode. Here we have a thermistor. And a thermistor is essentially a device that measures the amount of resistance. It's basically a resistance thermometer. Okay, that's what you need to know. This is essentially the sensor, right? And so we're sending obviously electrical current to it because we need to be able to measure. That. If we have a cathode, we need something else that's positively charged, right? Because it's flowing from negative to positive. And that is where the anode comes in. So the anode is positive right here. And this is often made out of lead. Okay? So we've got our cathode. And essentially, right, as oxygen comes in, we have all of this electricity going through the cathode to the anode. And the hydroxide essentially is going to flow from here all the way to the anode. All right. And yeah, so this here, hydroxide, but which is also known as the ion transfer, right? Or migration, you could call it. And so essentially this is how it works, right? You have a flue gas gun. My battery is low on my laptop, so if it randomly cuts it, I'm sorry. And we basically have a sample tube here. You stick that up. The oxygen is going to flow in, right? It's going to go through this gas permeable membrane, right? And this is entirely filled with water, H2O right here. We have a circuit here that is, again, providing, you can see this is negative, this is positive, right? It's going to flow through here. It's going to go up the cathode line to the anode. It's charging this cathode right here that's made out of platinum. And we got water and we got oxygen that's entering. And what do we get as a result? Well, we get hydroxide. And that hydroxide basically has to travel all of the way to the anode. And when it gets back to the anode, that electricity gets transferred and it keeps going round and round in a circuit. Over time, this anode is going to rot away. It's going to deteriorate. So every few years, you're going to have to replace that. That's just how that works. And I think I explained what a thermistor was, right? Which is basically, it's a resistance thermometer, which is a sensor, okay? That we use to measure all of this, All right, and this here is our analyzer. And so that is how the first flue gas, analyzer works.